everyone, we're going to pick up where we left off last time with object-oriented development. I skipped over an example last time just because, well, actually to be honest, I wasn't sure how cleaned up the example was. So let's go to what we were looking at. Hopefully I can find it in here. Simple coded example, I was going to share it with the drive. Well, it's going to be shared on the drive. And it's going to be covering, I'm going to be looking at students, we're going to be looking at destructors, we're going to be seeing dynamic arrays, we're going to be seeing static arrays, we're going to see code reuse, we'll see all sorts of wonderful little things like that. So let's dive into this. I want to look at the student class that we were looking at last time, or some previous time in the past. It's a lot more convoluted than it might seem, so just being aware of that. The rectangle example's easier or better for a nice clean little example, but the student one, we can expand on it and we can deal with certain little quirks of the C and C++ language. So here we go. I'm going to get here. I notice I even have a version of the student class that I'm going to be dealing with called Stu. That's not the person's name. It's just abbreviation for student. It could be anything I want here. And we could do a bunch of different things for it, by the way. I can make a non-dynamic student, like I do here, a student 2 in this case, or I can make a dynamic version of a student by calling new. So student 2, I get a pointer to a student, new student 2, and then I'm going to call a particular constructor. Now you're probably wondering, why the hell would I ever do that? Well, because you do not know how many students you're going to have. So if I know I have exactly 10 students, fine. But if the number of students I'm getting from a file is going to be different, and that happens far more than you might expect, right? You may have an array of different students. Maybe you have the user type in what this, every time they want to add a new student, they type in something. Well, in all of those cases, I want to have I end up needing this sort of thing. I need to have a dynamically allocated student object, and I get a pointer to it called pstu2, right? That's the name I gave it. It's actually just a pointer to a student. Now, I could also, let's do this. Let's also throw another one in here, student2. P student2 ID is, and I'm going to call it P underscore student2, and I'm going to get the ID for that student, and I'm going to do an inline. Great. The reason I have these two different versions of it, what we're going to see today in class, or somewhat in class, while you're sitting there watching me do a boring video, what you're going to see here is I'm going to go and I'm going to make the version of a student the way we did before, which is all in one file, but that's not recommended. And so we'll see the other version of it, and it's already pre-canned because I didn't want to rewrite everything all over again, but it's going to be in student H and student CPP. That's what we're going to do after that. That's what where the student class here is defined. So I have the in-file version of it. That is not the ideal solution. That is that if I need to hack something out, if I need to throw something out the door, sure, throw it in the same file. But most times, or at least a lot of the time, if I want a new class, I will put it in new files to make sure I know where the heck that is. Because as you might imagine, I could squirrel away all sorts of classes and objects everywhere in my code, right? I could throw everything in main. I get a whole bunch of classes in main and compile everything in hunky-dory. But when I go back 4 months later to find, Rec2400, or I go to find this object or that, this class or that class, I won't be able to find that thing again. It's all just sort of stuffed in the one file, where I need to worry about the order things are going to be put in. I need to worry about whether I can reuse this. Let's say I want to use this student class again. Well, if I want to use the student class again in some other program that I'm going to write, I gotta copy and paste it from here and move it over, and I gotta find it again and figure out make sure I can just pull it out. The cleaner or better solution is I have a file or a pair of files per class. So every time I make a new class, I will make a new pair of files, a header file and a CPP file. So we'll talk about that in a lot more detail very soon, but let's have a quick look at, oh, and I have a grade list as well. That was another example where we were looking at. So here's my, I'm going to make a, this will automatically, when I make an object of this type, since it's not dynamically allocated, as soon as I call main, I am making this object stu2. So I will call a constructor automatically. I don't choose when the constructor is called. Oh, that's the other reason why I might want to use new. If I don't know what the data looks like beforehand and I want to call a constructor when I need it. So if I have this, I will automatically call my constructor. Heck, let's do that. Let's plop in a breakpoint just to see this in action. And we will see, and I'm going to put a stu2 breakpoint right here and a stu2 breakpoint right here. Okay, and when I call a constructor, I'm going when I call new, I will pass in two different parameters in here, and then I'm going to output what the heck I see. That's it. Interesting, right? I just want to make sure my data looks right, so I'm going to have some kind of output statement getting the ID. So I will get the ID from the object. The object can tell me, hey, this is my ID. So I get the ID from it. A getter and setter, we'll see that very soon. And then I can also get the ID from my dynamic object right here. That's what this thing is doing. Later on, if we want to look at this, we can look at this example here for how to add a grade and then how to calculate my average. Right? So I may have a grade list, a series of grades, and then I can have some function called calculate average. So I add a bunch of grades to my grade list. How big is it? I don't know. It should be able to hold whatever I throw at it. And it's a magic box. I throw stuff in there and say calculate, and it calculates my average. That was one version you could have done for the example we did last class, where I said, how do you calculate the average for students? Well, this would be all of your assignment grades. You throw them into an assignment grade box, or magic box that can just calculate your average. Okay, so let's look at the student class. Here we go. I'm going to make a class called student2 because I'm very original in my naming convention. I'm going to have a name for the student. Notice the name is, I'm using a character array. I could have used a string. That would have been fine. But I'm going to use a character array for now. Well, because I'm just sort of used to character arrays, I guess. I'm sort of anal retentive that way. All right, and I'm also going to store an ID. By the way, the string, if I used a string, it might be a little bit quirky. Because I have to clear the string and then add things. Okay. So here is what my constructor looks like. If I pass in a constructor with nothing in it, I'm going to make a brand new array, start with a name. There's going to be nothing as the first character, so it's going to be a blank that the name is quote unquote. So the name, let's do this. Name is, there you go. I'm going to set an ID to some default value. That's it, right? This is a blank does nothing constructor. I need constructors for a very important reason. Every time I make a new object, I got to set things up. That's what a constructor is for. I'm setting up the table. I'm making sure everything is prepared properly before I use it. Right? I don't just go trying stuff. Right? As you might be surprised, but I actually prepare the lectures before I give them. I don't just sort of show up and just start talking about random things, right? I do a lot of preparation to be ready to give a lecture, to have the examples that I want to provide, right? It is the setup. Everyone has a setup. If you're going to a party, you have a setup to your party. Then people show up, you have your party, and then afterwards you have a tear down, right? You have a clean up all the puke or whatever you're talking about for a party, depending on the party. Let's say tea party. They're very, very polite. They're clean up the crumbs from the tea party. And so here's my destructor. When I'm cleaning up the tea crumbs at the party, well, I've created a dynamic array here. When I make one of these objects, I create a dynamic array. I gotta clean that up. Otherwise, that's on me. I still have access to that pointer. If I give back this object and I don't clean that array up, bad stuff's going to happen. So if I don't call delete on this array, that means my program would still be reserving this 100 character array. I give back the object itself. Nothing's given back the name here. I have a memory leak. I have a 100 character array. Every time I make one of these things then I delete it, if I did not have this part right here, I'd be giving back the object, but not that big array that I made. Right? Every time I call new, it's not related to anything else. It's just I'm asking for memory from the system. It's related to other stuff, I suppose, but it's just I'm getting a pointer to it. So I give back the pointer. It doesn't mean I gave back the array. If I'm giving back the array, I have to call delete. So here we go. I'm making a new array, and if I'm calling new in my constructor, I better be calling delete in my destructor. I gotta clean that thing up afterwards. So if I call new, then I should call delete. And then afterwards, just to be paranoid, you don't have to, but I like being paranoid, and you probably should be paranoid too. I set it to null, right? I've cleaned it up. It's still pointing to the thing I just gave back, right? I gave the keys to my house to somebody else. I sold my house. I still have the keys. I don't want to be tempted to go back into the house. Hey, did I sell the house? Oh, let's go back in my house again. No, you give back the keys. You don't want to have anything. So this is, I'm not going to point to what I had before, because there's no way of knowing that you've given it back later, right? If I've given back the pointer and somehow I get something, I don't know if I've given it back. So as just a general habit, when I clean up something, when I get rid of a pointer, when I call delete, I want to set things to null afterwards. It's the safe thing to do. Other languages do that for you for free. C and C++, in its infinite wisdom, do not do anything for free. Right? It's slightly slower to do all this extra work to give you a null pointer afterwards, and so they just don't do it. And so you have to show the discipline that you need to make sure that things, C and C++ is very much like going to the gym by yourself, right? You need to have the discipline to do things the right way and not just sort of random. If you do some random things, you're not actually necessarily helping yourself. If you do a half-assed job, you're not necessarily helping yourself. You need to have a discipline to make sure you clean up your arrays and then set your pointers to null. Otherwise, bad stuff's going to happen, but it's not going to happen today. It's not going to happen tomorrow. It's not going to happen on your assignments most times. So that's a good thing, I guess. It's going to happen 3 months, 4 months later, right? When you go to look at your code again, 3 or 4 months later, if you're doing a class project, for example, that's a term-long project, it will bite you about 2 weeks before the end of term. And you will not know what the hell you were doing 3 months earlier. That's why we want you in the good habit. Unfortunately, you don't get to get little minor pain points to show you to prove that particular lesson. Some of you might, but most people won't hit that pain point until they get off in the real world and they go, "Oh, that's why." So, C and C++ don't do any, much like washing your dishes, right? If your mom or dad let you don't force you to wash your dishes every single day, not a real big pain point. Let's say they go away for the weekend, you don't wash your dishes. They come back, they get upset with you because you didn't wash your dishes. Fine. But you didn't really experience what happens when you don't wash your dishes for, a week and then you have ants, right? It's the when you're actually on your own, that's when it bites you. Anyways, so here is my destructor. I have a constructor. Sorry, I have not a constructor. I have a getter. I have my constructors up here. I have a getter. So here's my getter. These are sort of standardized terms. And this is a setter. I know, crazy. One says get and one says set. Yeah. Getters and setters. So one is I set the value. The other one is I get the value. The reason I have this, and I have it up here, these things are private variables. Nobody but the student2 class gets to see that. The reason you don't want other people doing that is you do not want other people being able to change your name or change your student ID. If you have someone set your student ID, they better be qualified to set your student ID. Okay, so let's compile this thing up and see what we get. Hopefully it's going to compile. If it doesn't, meh, we'll find out. Okay, I'm going to run it. I have 3 breakpoints in here. So let's see what happens. Breakpoint number 1, right at the top. I'm going to make, so this is where I am right now. Let's do one step further, which should cause the second breakpoint to go off, which is inside the blank constructor. So function F10 inside the blank constructor. This is when I make a brand new, notice the name is blank and the ID is blank. So the student2 object has that value. I call the constructor automatically, even if you don't realize you're calling the constructor. It gets called, but I can't make the object when I need it. It's not just in time. It's not when I need it. It's I make it as soon as I say student2 stu2, I will make an object. Whether I have the data right data or not, whether I have the person's name or not, is irrelevant. So next, I'm going to call a constructor with parameters. This will call the other constructor. Why do it will call the other constructor? Because it has 2 parameters. The other method has, or the other constructor has 2 parameters. It has a name and an ID, so it'll match what I called. So I can now go into that particular constructor. Well, actually, I can just continue and I'll automatically hit it. So if I press continue, I'll automatically go into, well, let's go F11. Let's step into my function. So F11, step into my function. Oh, there, I would have hit that second breakpoint. Great. Notice the in name is David Sprague. The ID is 4000. I will make a brand new array, which will have nothing in it. I will copy in name over there. What I should have done instead of this 100, by the way, is figure out the length of in name and do that +1. But I copy over 100 characters over from this thing to this thing. We're assuming that they're about the same. And then I am going to change my ID. Boom. I'm done. I do my printout statements. And let's look at my printout statements. The ID is 0, the ID is 4000. Exactly what you'd expect. This one has the default, which is 0. This one has an ID of 4000. Notice I'm getting it from the objects themselves. The objects know what data they have, and then you use methods to get it from them. Hey student, what is your ID? That's what we're looking for. Alright, I'm just going to finish this off because I don't like stopping my code early. I want to look at one other thing here. So let's go back up, and yeah, we're going to change my name to Susan. So let's go back up here because I find that funny. Okay, and we're going to use SetID, not CertID. There you go, SetID. And I'm going to put a 0 here. And you're probably wondering, why the hell would I do that instead? And just in case that's important information. All right. Why would I want to do that in my constructor rather than just setting the ID, right? Why am I doing all this extra stuff here? Because I might want something like that. So where's my set ID? My setter method, int ID. Okay. If new ID is less than 0, new, I don't want new IDs. This new ID. Right. Then I'm going to set my ID. I'm not going to change anything at all. Let's do this. If it's greater than 0, ID is equal to new ID, and otherwise ID is equal to 0. So if you give me a negative ID, it'll set it to 0. Or maybe we'll set it to 1. Let's try that. Okay, and then less than, as long as it's greater than, as long as it's greater than 0, we'll keep the number. Otherwise, we'll set it to 1. Yep, that should work. Okay. This is the reason you might want to call member functions, right? I call setID because I want to check to see if the ID is done correctly one place, not 5 places, not 2 places, not in this constructor and then in this constructor, not in this constructor, then in this constructor later. No, I want to set the ID, just be able to set the ID and not have to worry about the fiddly diddly details. I don't have to worry about, oh, on a Tuesday this thing breaks, right? I want to just be able to call and just set the ID. And somebody has done the right error checking to make sure setting the ID works correctly. If you wonder where this comes in handy, I'll probably go over this again. It's this right here. See what my mouse is doing? See how it's not going off the edge? Why is it not going off the edge? I'm actually scrolling to the left and nothing's happening. Nothing's happening because I can do a method that sets the mouse position, and when I'm setting the mouse position, if it's less than 0, I just set it to 0, and I get a hard wall in my mouse position. That if I do that special exception testing everywhere, I have duplicated code 40, 50, 100 times in my code, when really I want it to be done once and done correctly in one place. I want to be able to reuse my code. So if I write set, I make set ID, I can reuse that function here, and when someone wants to call set ID, I can use it there. I can use it all over the place. I just need one place where it's done correctly. All right. So if we run this again, what we should see is this default value that I put in here, it will actually be the value, it'll be the value 1 at the end now, because setID says no, if you give me a 0 or less, make it a 1. It binds it to 1 or greater. So let's have a look. Boom, 1. Student ID is 1 over there. Oh, that's something weird. We have something strange going on here. So I call setID. The inID is going into here. I then call setID if my new ID is greater than, oh, duh, return. Or I can use an else. Let's use an else. Many people like else statements, so else. And I need that. There we go. And I test my code and make sure it works before I move on, because every time I don't, it bites me. So there, 4,000, and it's working again. Great. Here's the next thing we're going to be looking at. I don't want it in one file, so I don't want my here we go, my student2 class. I have a class right there in my file where student main is, and then I'm also going to put student grades in the same file, my grade list class in the same file. It's just going to be a pain. What I want is to tease out these into a different file. Maybe I'll do that with the the grade list thing as well. So here's what I'm going. So let's go back to my presentation. Actually, let me do a brief pause and then we'll go to our presentation.